So hello everyone, welcome to today's daily LeetCode challenge, and today is day 17th. Today we have a nice question with us. It's a medium level question. It talks about the trie data structure. See, before starting this problem, I will try to explain what trie data structure is, and only if you come to know how powerful it is, you will feel like solving this question. Okay. So we are talking about the trie data structure, and it like you might have seen like in Google when you are trying to search something in the autocomplete feature, the spell checkers when you are typing in what documents, or the prefix matching ones. These are all like implemented based on this data structure only. And one more thing is like, for example, we are taking a creating new Gmail ID. You might have seen that it won't allow you to take the already existing one. How that happens? Also, that also is through this data structure only. So anything related to like spellings or like auto completions or like searching of words, all these things are done through this data structure. So yeah, I will quickly give you an explanation of how it happens. So you can also go through the Wikipedia page. They have given some sample algorithms. You can go through them. So yeah, this is how it looks, and I will clearly I will explain what are the data members. See, each green thing which you are seeing here, each node you are seeing here is actually a trie node. In our function, we are explaining. Yeah, this is the class I'm using for trie node. Okay, and to show how it will be, yeah. So for each trie node, which I will go to the diagram again. See, you will be having an array first of all of 26 members. 26. The array length is 26 actually. 26 refers to all the characters here. See, in the question they have clearly mentioned that it will be lowercase English letters only. Okay, and the prefix length. Okay, it doesn't matter. We have to implement this. Okay, these are the function: insert function, search function, and starts with that is a prefix finding function. We have to implement. For that, we are using C. Trie will be like the one diagram I showed you, and each node of the trie will be a trie node class. Okay, object of trie node class. And what are the member functions of it? It will have two data members. These are the two data members, and these are the member functions. So be clear with what I am doing. These are the member functions, and these are the data members. Okay, what are these things? See, this is a boolean, as you can clearly see, is end. Suppose, okay, I will go to the diagram once after I explain this. See, this is array of 26 length. So here we are 26 means letter from A to Z. This is for each of the elements. Okay. Now coming to the diagram of it. See, for example, I am at root. Okay, I am at root. Clearly you can see, and I have to only see all the words starting from it. For example, BID, bid, BEA, BEI, BSEI. These are the words we are capturing in this structure. Okay. So when I'm at root in my data structure, which like the array which I told you, it has 26 elements. Of that, only the one which represents B and S will be not null. Please note these points. Of the data structure, which is the array which I showed you, when I am at root, only the ones corresponding to B and S will be not null. All the others will be null. Similarly, when I am at the node B, this is the second this is node. When I'm at the node B, of my data member that array which has 26 length, of that only the ones which are corresponding to E, I, and U, they these are the only ones which will be not null. Rest all will be null. Okay, that is how it's being done, and similarly for others as well. Okay, now coming to the see, when I am saying not, whether it's this element, this is end means when the structure is going to end, if this is the end to it or not. Okay, if that is the end to it or not. For example, they have not given it. Suppose a word ends, for example, APPLE. When the E comes, the for that not only the is end will be true. Okay, for all others it won't be true. For the example which I gave, please rewind and go through it. I'm sure you will be able to like explain and understand it. So these are the data members. I will quickly go through what are that. Okay. See, our main class starts here. Till now, we are only explaining what each node is going to have. So each node is going to have array of 26 thing, 26 members, 26 like length, and the boolean value. Now contains key at the level the node which I am. I will see the this you can explain this understand it like an array. Okay, it will be an array. This will be corresponding value for A. There will be corresponding value for B. Okay, A then B like that. It will be till Z. Okay, these are values. For it corresponding value, there will be T node. For corresponding V, there will be T node. Okay, this is how to understand it. Now, I will be checking for the character which we are sending here. whether we have anything for it or not. Whether, for example, ch is a in this case, whether for a I'm having a like branch or not, that will be checked through this. If we are having it, we will be returning true. Otherwise, it will be returning false. So this returns a boolean value. Okay. Now coming to put, whether suppose I am having a and z, but I am not having a b, so it will be none here initially. Okay, it will be none here. Now when I'm in, suppose this ch is b here, so at link, see what I'm doing here is to gather number. See, I am not going to access through a, b, or z. Okay, I'm going to access through 0, 1, 2, 25 like that. So I'm subtracting, for example, b minus a, the ordinality of b, that is the ASCII value of b minus the ASCII value of a, it will return 1. So at length 1, like at index 1, I'm going to see. If there is nothing, I will be like appending this node to it. Okay, this node is a tri node object again. I will appending that to it. Okay, so it will become something like a tri node object corresponding to b. Okay, now coming to get. Suppose I have a value already for a. I want to return that the link to that. That's what I'm doing here. Return. See, this is self dot. All these things are like Python constraints. I'm not explaining them in detail, but this is how it is being done. To access anything, we need to use the self. Okay. And from object also, when I'm calling that function, I will show you. We need to use the self. Isn't. So I'm just making it as a isn't equal to true. And when I want to know if isn't is true or not, I'm just returning this value true or false. So this is a true false value. This is something which is of length 26. Okay. Now coming to the real question. This is where we are going to implement it. At the constructor, this is how the constructor is being written. At constructor, I'm initializing root variable, which is the object of trinode class. Okay. Now we have to see they are asking only three functions: insert function, search function, starts with function. So I will go to that one by one. So first coming to the insert function. Okay, I'm in making node to point to my root. Root, as I already shown, it let us consider it to be null initially. Making another variable point to my root. This is the word which is to be inserted in my tree. Okay, in my tree. So for each character of this word so I represent each character of this word. Okay. First, I will check in my root variable, node is root here, whether I am having a tree already existing with its having, for example, see, for example, in this diagram, I have already a word existing with T. There is 2O, okay, TO. For example, I want to insert another word, for example, TEA. So T is already existing. I need to enter only the remaining characters, okay. For example, in this case, TO is already existing. I want to enter TEA. So T is already there. I need to enter E and then A. Okay. So T is already existing. I did not do anything with that again. That's what the idea is here. So if it is already existing, if if it doesn't exist, then we need to insert it. That we are using put method. And if it is already existing, we will not implement this code. Okay. We will be simply returning it. Whatever the link to that, we will be returning it. Okay. And like that we will do for all the like all the I characters in the word, and after that we will set the end to true. What set end means, it will set the is end to true in that the last node. Okay, this is the first function. Now coming to search function. For getting search and the starts with function, we need to understand what is set prefix, search prefix function. Again, same thing. I will initialize my variable node to my root. For each character in the word I am going through it. So if the node contains I, then it is valid and good to return me the link to it. If it doesn't contain, return none. That means the prefix is not present. Okay. And in case it is present, that means only this part is getting executed. Finally, I'm returning the end node of it. So understand one thing. If the prefix exists in this case, if the word exists as a prefix, I will be returning the last node containing it. If it doesn't exist, I will return none. These two things please keep in mind because we are using this function in my other functions. Now coming to the search function, search means I want to search a word if it exists in my tree or not. What I will do, I'm search passing this in the search prefix function. So it will return two things. If it exists, it will return the end node of it. If it doesn't exist, it will return the none value. Okay. If node is not equal to none, next condition. If node is not equal to none, Then I will check if, see, this is a word after, it's not a prefix, okay? So I am again checking if isn't is true for that, for the last node. If isn't true, that means it's an end word. It's not like in between word. For example, we have to as a toss word. Okay, in that want to search to word, to. So to is present in TOSS. Okay, but is not the end. Like when I come to TO, SS is also present, na? So it's not ending at TO. That's why if isn't is true, only then we can conclude that the word is present. Only then I will be returning true. In all other cases, I will be returning false. Okay. Then comes to starts with. This is where like for TO is TOSS is the word. I want to search if TO is the prefix of it. It's correct, right? TO is the prefix of TOSS. It should return true. In this case, we will not check this condition. We will ignore this condition and we will only check if it's returning not null value, and we will be saying it's true. Okay. So I'm initializing node starting. So node is getting what is being written by search prefix function. So search prefix function will return the end node if the prefix exists, and it will return none if it doesn't exist. So I'm just checking if node is not equal to none. If that is true, that is the case, I'm returning node. Okay, starts with function. So yeah, that was all. So see, before doing these questions, you need to understand what this data structure is. If you only appreciate this data structure, you will like feel like solving these questions. Okay, how important it is and why it is beating the hash map functions in case of searching, in case of auto completion. Only then you will get to know how it works. The idea is very simple here. If we have already have something, we are only going to build the remaining part of it. Okay, we're not going to create another branch of it. For example, if I have TOSS toss, okay, and if I want to enter the word TODAY, so I will continue only after TO. That is only a DAY I need to end. TOSS is there, so TO is already present, and after TO I only need to enter the DAY word, so it will become TODAY. So that is the basic idea of it. If you rewind my video and try to understand that, you will surely get it. Okay. So that's all for today. Thank you everyone. Thanks a lot.